before we get into disaster recovery, so we need to identify what we call it as disaster, right? See, outages happen. Okay, so downtime is inevitable, right? So system failure is very normal in IT or any electronic gadgets or components will definitely fail, right? And we need to find a way to prepare ourselves better on how we can quickly recover from disaster, or how you can provide continuity of services for your business application or for your business, right? So when I say disaster, I would keep it very simple. So when there is a financial impact because of due to downtime of your application of your systems, then you can call that as a disaster on a very high level. Okay, so that if there is a financial impact, then that's where you might go bankrupt, or you might go you will have some financial issues. Then I will just term it as disaster. But in general, like when you talk about cloud providers or their way of explaining it, they are calling it out three categories of disaster. Okay, I would just go with this three categories of disaster that might happen. The number one is the technical failure, right? That everyone understands. See, with electronic component, disk might fail, CPU server might fail, the motherboard on the server might fail, the network component might fail, and there are a lot of other technical failures that might happen. Even there are certain things which can be technical in nature, or which can be kind of functional in nature. But see, there can be power failure, network failure, cooling failure, and so on. So these are all technical issues that we need to find a way on how we can mitigate when there is a failure, technical failure event. Second is natural disaster, right? Natural disaster can be floods or earthquake, and maybe some kind of I think that will be under human action or human people call it as human errors or human actions. See, human action, the reason I did not call out any war or any particular um, uh, community, communal disaster. So all those things comes under human actions, and human error is like you have accidentally deleted something, or accidentally modified something, and which has brought some downtime during your you might have done an unauthorized change or unauthorized activity, something that has ended up with a disaster, right? So it can be an inadvertent misconfiguration of something on your system, or it can be a large war. It can be a lot of different things, right? So these are the three different potential categories of how a disaster can happen. So each of these potential disaster will also have a national level impact, or it can be a geographical impact. It depends on how big is the issue that is happening. So it can be a local city level issue, or it can be a regional one, or it can be a countrywide issue. It can be global, continental, and so on. So there are lot of different stuffs which can have different level of impact. So we need to plan for the strategy on how we can overcome these three failures that might come in a IT environment, right? So we know how disaster can impact us, and now as a solution architect, we need to find out a way on how we need to build a disaster recovery strategy. So disaster recovery strategy, we can plan for it with there are a lot of different stuffs involved. Okay, there are stuffs like budgeting, the criticality of the application, the availability of the application requirement, right? Sorry, the availability requirement of the application, and there are a lot of different stuffs that we need to take care of. Now, the disaster recovery as such, we can call it as a process. Just a second. We can call that as a process of preparing for and recovering from the disaster. right? So disaster is inevitable, right? Sorry, the failure is inevitable, and we need to. There is a sorry, sorry. There is a very good proverb, or not a very good proverb. There is a proverb that says like everything fails all the time. So this is by the Amazon, one of the Amazon senior person. They have called this like everything fails all the time. So that means we need to plan for the failure in an efficient way. Okay, so we should always think, what if a server fails? What if the OS fails? So failure is inevitable, right? There might be a server level failure, or there might be OS level corruption, or there might be, as I told you, network level or building fire accident. Then there might be a lot of different scenarios. So we need to be prepared for all these things: software update or software corruption, or it can be any significant event, right? So in order to have a proper planning, so we call it as disaster recovery is nothing but process of preparing for and recovering from any of these failures. See, this is not the complete list. As I told you, we can categorize it into technical, natural, and human action. Let me put it here so that you can also see if I miss some examples there. So we need to prepare a strategy. See, as an architect, we need to have different strategies put in place. And when we are defining the strategy, as I told you, you need to think about a lot of thought process has to be put upon, and then we need to have the budget for each of the application, and then we need to understand the criticality of the application, and we also need to understand the availability requirements of the application, the SLA, service level availability of the specific application. So there are various ways that you can protect. There are various different DR pattern, I would call. Okay, I will explain what are the different four different DR pattern that we have. And then before we get into that, we have two important acronyms and concepts which we need to be familiar with: recovery time objective, and then recovery point objective. So these are the two important elements that we need to identify from the business owner or from the customer before we plan for any recovery objective. So recovery objectives are categorized into two different group: recovery point objective and recovery um, time objective. So there is so this is all part of your resiliency and availability strategy. So people have a wrong perception that high availability and disaster recovery are the same, but they are complementing each other. So I will help you understand how they are closely related to each other. See, disaster recovery planning is a plan of action that is put together by a team of people. So they will have a DR run book. Okay, so they call it as DR run book or DR playbook. Okay, so whenever there is a DR issue or whenever there is a disaster, then they will follow this run book or the playbook. So this is nothing but a plan of action or a plan of structured action that the team has to take, and it is very detailed to address different failures, and it can help recover from network systems and all such attacks and failures. Even there can be ransomware attack, that is also these days very common, right? Attacks and so on. So we need to put together a very good high implementation plan that can quickly help customer recover from any natural or technical fault. So how do we plan for it? So whenever there is a natural disaster, see, cloud services can be disrupted by natural disasters. See, here we are hosting all the application on AWS platform, and we are talking about how we can have a kind of recovery plan, right? For example, if you're talking about natural disaster, See, generally how we can, we have multiple AWS regions which can be utilized to have your servers scattered across different geographical region. If in case a particular region goes down or something similar to that, but not all the customer can use this because of legal requirements, security requirements, data residency requirement. They cannot have everything in multiple different data center. And maybe to mitigate some small disk level failure, server level failure, you can use this availability zone option or any availability strategy to have multiple systems running your applications and so on. And to avoid the human catastrophes, right? So they also call it as human catastrophes. So for human catastrophes, we can also take some kind of backup and some kind of replication to ensure that you have multiple different systems, or you can also take snapshots on a frequent basis to quickly roll back if there is a particular issue in your organization. So now coming to the solution that we have in hand with AWS, we have a tool called AWS Elastic Disaster Recovery. So this is the tool that we will be primarily using for today's demo on how you can use this tool for a disaster recovery, and see if in case you are currently working for a customer and if they are using um, the old tool is Cloud Endure. See, Cloud Endure was a separate organization. It was acquired by AWS sometime back, a few years back. And what they have done is they have taken this product called Cloud Endure disaster recovery product, and this is actually deprecating maybe I would think end of March, I guess. Okay, so I'm not pretty sure, but I think if I remember it correctly, end of March 2024, Cloud Endure product will not be available, right? And the customer has already started moving away from the Cloud Endure disaster recovery to the AWS native Elastic disaster recovery service. But again, the product is completely developed, and almost 95% of the stuffs that we used to do with Cloud Endure DR is the same. See, if you are still interested in learning Cloud Endure DR, I have a detailed theoretical session plus a demo using the Cloud Endure tool. You can just follow that. But AWS EDR, it can help you with replicating the contents from on-premises, your VMware environment, Hyper-V environment, and you have a lot of different other clouds like GCP, Google Cloud, and Microsoft Cloud. You can keep replicating, and you can get you can maintain a duplicate recovery site from on-premises as well as from other cloud, right? See, unlike your on-premises traditional disaster recovery model, the cloud model is little different in a way that see in on-premises, most of your resources in the disaster recovery site, it will be kept idle, so it will be just a passive content. Whereas here in the cloud, you can have a very cost effective strategy with the AWS options to maintain up to date copy of your store servers on two different geographical region or two different availability zone. And it will also have a lot of cost impact because the EDR tool is designed in such a way that it will have only the latest and the greatest of content that you need for recovering your failure or recovering from failure. So it will remove idle disaster recovery site resources, and it will keep updating it, and you just pay for your fully recovery site only when you need it for drills or recovery. Otherwise, you don't have to really pay for it. So it is very cost effective, and it has got very good maintenance options, and you can have only up to date copy, and you can also have see, on premises can be very cost involved, and you have to pay a lot of cost to maintain a duplicate site here. So let me go back to the console. So if you go to your console and if you start searching AWS Elastic Disaster Recovery Service, you can get this option. So they call it as scalable. Yeah, see, second point itself, they're calling it as cost-effective application recovery to AWS. So it's definitely a very good tool. It can be used for very large scale migrations, sorry, very large scale DR scenarios and replication, and it can also be used for very small sized replication as well. So it is very scalable, and you can keep having as many number of systems as you want. And I will explain about what are the different systems that are involved in the technical replication and the DR scenario, right? So let's use the same standard definition from AWS. So AWS EDR, it minimizes the downtime because it is the tool for having replication done between two different data centers or two different geographical region, and it is very fast and reliable, and you can replicate from on-premises as well as from the other third-party Microsoft or Oracle or Google Cloud, and you get lot of different options. AWS has got a lot of different storage varieties, and you can try to replicate the content to the appropriate destination on the AWS side. Like if it is a object storage, you go for S3, and if it is a file system or a file share, you take it to EFS or FSX. So it depends on case to case. You can just go for what would be the appropriate stuff. So in order to have this EDR, there is a step-by-step procedure that we are going to follow. So we will follow the steps shortly, but before we get into the actual demo, we will also see, like, if I've got something here. Yeah, so Elastic Disaster Recovery, we have to set up the console first, and then we can, it's pretty much similar to the last week session that we had on migration, right? What we did, we had the source system, and then before we have the final system, we also had a staging environment. So the staging environment is where the content will be continuously copied over or replicated, and then when there is a need, you kind of bring the system on the actual production network, right? Until that time, you will be having it on the staging subnet. So similarly here also, you will have option to go and do some testing. Staging can be done, and once after you find things needs to be improved, you can just fail over and then try to test whatever you want. And then if there is a need, you can also go back to your source side. It also provides you a fail back option also. It's not just about failover. Failover is switching over from the source site to the destination site. And if the primary site comes back online um, after the issue is sorted out, you can also go back to your primary site where you have the better coverage and users and so on. So you have both failover and failback option in okay. So you have these two terms, failover and then failback, and then some people call it as a drill, DR drill. Okay, so now let's understand what are the different the terminologies first, and then we will move on to the different strategies that we can follow in AWS. So with uh, with general disaster recovery, we have two common things: recovery time objective. So it is, both of them are measured in time. Okay, both of them are measured in time, and this is the downtime that we are going to have when there is a disaster, right? Let me just get you to that appropriate slide here. Yeah. So see, the disaster will happen anytime. It will not notify us, and then maybe there we might see some symptoms. We might be able to guess something is going to happen. But then, so if disaster happens, the time it takes to recover after the disaster is called the downtime. So the people will be waiting, the application owners will be waiting until the system is coming back, right? So how quickly must you recover? Like, recovery time objective is how quickly should we recover, or must you recover when there is a disaster, when there is an outage, and what is the cost of the downtime? So how big is the downtime? How critical is the impact? What is the priority of the application? Like, what is happening in the business? So how much is the loss? Okay, so financial loss is what they are talking about. And then we also need to understand how quickly we need to recover. So this will be defined in the SLA document. So SLA document will have, or the operational level agreement document will have both the information. How much is the recovery time objective? So they will have 4 hours or 8 hours. So based on the criticality of the application, so they might have some manual way of working until the system is coming back. Okay, so we might have to have an alternate way to mitigate the issues. See, if example, if the online application is down, so we should start doing the booking with manual receipts and so on, something like that. So we have to have some kind of alternate plans. Recovery point objective: when the downtime happened, and how much data can you afford to recreate or loss. See, for example, if a disaster happens at 10 a.m. in the morning. So, for example, if you have a backup from 6 a.m. in the morning, so those 4 hours time is the data loss. So the 10 a.m. The issue has happened, but we have had a full backup that ran at around 6 a.m. So the 4 hours time is the duration where the complete changes that the team has made, the business has made, has completely lost. So the data loss is actually everything is measured in time. See, you cannot say 2 GB, 4 GB, 6 GB. See, one day you might have 5 GB of data changes in 4 hours. In another day, you might have 10 GB of data changes in 4 hours. So we cannot measure it by capacity. Instead, both RTO and RPO will be measured in time. So how much time, how much hours there was a downtime, or what data we have to go and restore it from the backup. So it can be a snapshot, or it can be a backup, or it can be a replicated passive content. So we are relying upon this particular recovery point objective on when we have a full recoverable backup. How much data we can lose, or how much data we can quickly recreate. We recreate from the manual ledger or manual way of creating the thing. So this is how much you can afford to recover it. So both of them are measured in time. Both RTO and RPO are measured in time. So this is the time when we have a successful backup or content that we could easily recreate. See, it depends on case to case. In some cases, customer will go for a different strategy. It is based on the criticality of the application and how much budget they have. Okay, now coming to the disaster recovery strategies, the DR plan or the DR strategy. So there are 4 different strategies that we have. So it is all based on the budget, as I said. The very first one, generally what customer try to achieve is to take a backup and restore. So this is the basic bare minimum option. First option when it comes to disaster recovery, they call it as backup and restore. And the second option, they call it as pilot light. Okay, and the third option, recovery option, is called warm standby. And then finally you have multi-site. Okay, we will see all these scenarios in details. I have got some architectural diagram on how to understand this better in a diagrammatic way, but for now I will just explain. These are the 4 different patterns or strategy every customer will take to mitigate from a specific failure. Right, let's go and understand a little bit of these one by one, and then we will move on to the slide to see what details I've missed, right? So see, when you have, this is all depends on criticality of the application, budget of the application, importance, and availability requirements of your application. So all these stuffs dictate how we have to plan for the DR strategy. See, for if it is a low critical system, low impact or low critical systems, or I would say low priority systems, you can go for backup and restore concept. See, generally what we do, we go and take a daily backup or incremental backup on a daily basis, and then we use it on a 20. See, when you're taking a daily backup, so we are taking only 1 day backup. So that is, we call it as 24 hours RPO, which means if there is an issue today evening or today morning, we can only recover from yesterday's full backup. So we have the complete date changes that has been impacted. If you have a 24 hours RPO for critical systems, you might have database level backup like an incremental or a differential backup where you might have continuous backups and snapshots happening. So that is different. But see, generally for an application server or a web server, changes might not happen very frequently. So you might go for a generic 24 hours RPO for those front end system. For back end system, for databases and other data sensitive systems, the RPO and RTO will be a little different. So here, what we have to do is, see, whenever we are going for backup and restore, we have to create all the environment in the DR site manually, because we have just done a backup and we have to restore it from the backup, and we have to create the system, and then we have to manually restore. So again, the RTO is also higher and depends on how much data we need to restore, the size, the complexity of the restoration, the application configuration. So based on the complexity, the time it takes for recovering from a disaster with backup and restore is very very high, and the cost involved for the backup and restore solution is very less. Okay, so cost is comparatively less. We are just taking backup. It can be just one, maybe single digit dollar value, something like that. Okay, and see, you need to restore the contents from the backup after disaster. So that is the main problem with this thing. So you have to completely recover it or restore the content either on the same site or in a different site, and then we have to bring up the system. See, both for both RPO and RTO, RPO is in hours. It can be 24 hours, 48 hours. It will be definitely in hours, right? So, but for Pilot Lite is something you have the data continuously replicated, so active, and then you have the data moving on to the passive side. So you will have continuously replication, but the services will not be used. So services will be idle on the destination side, on the DR location. Okay, and we will have some resources that will be provisioned. For example, minimal resources, like we will have maybe one or two servers instead of 10, 20 servers. We'll have minimal servers created. Minimal resources will be provisioned and kept ready. And in case of a disaster, quickly they will add additional servers, and they will scale based on the requirement. Scale and expand more based on the impact and requirement. So it's like a Pilot Lite. So you will not have a complete system up and running on the passive side, but you will have some kind of readily available system which can be quickly, cost is comparatively less again. So maybe I would say dollar. Okay, complete comparatively less. Yeah, fine. So here the RTO and the RPO maybe is in some a few minutes, or maybe in, yeah, it can be few minutes. Okay, so the next one is warm standby. See, the systems will be always running, so you will have a active cluster. So most of the request will be going for the primary site. There will be a small will be heavily used. The secondary site will have some kind of smaller workload compared to the primary site. Primary site will be heavily used, and when there is a disaster, the secondary site will have a lot of things. So again, here also you will scale and expand when there is an impact on the primary location. You will add more resources on the server at the database server level, and you'll add auto scaling and all those stuff. So you might have a lot of techniques that you might be heavily using it. You'll have the DNS settings readily available for failover. You might have traffic manager or load balancer that is configured to take over when there is any impact, right? So warm standby is, we have a system that is comparatively high, dollar, I would say. Then this might be this way, lesser So it's lesser, higher. Okay, I'm just taking that approach. So multi-site is you have both the environment, both the data centers are active, both the data centers are actively used, and both are equally contributing towards business. So there is no impact. That is like zero downtime for the customer application. Okay, so near zero data loss as well. So there will be very minimal if the replication there is a delay from one side to another side. Only that few seconds of data will be impacted. So this is real time. There is no data impact. RPO, RTO is near real time. There will be very few milliseconds latency, and this will be in minutes. RPO and RTO will be in minutes, but less than a hour. Okay, so maybe in a few minutes. So here it's near zero data loss, but cost is going to be very high. Okay, because you are completely spending on two different data centers, two different region. You have the same number of licenses used on the primary, secondary. So you are spending a lot, and you have to you will get a lot of benefit there. So yeah, coming back to the slide that I was talking about, in these cases, let me show you. So here, if you look at the RPO and RTO comparison, so these are the four different use cases that we were talking about, right? So in the four different strategies or use cases. So if you look at here, the cost is more when it comes to multi-site. That is understandable because like we have a lot of investment. You have exactly same environment in both primary location and secondary location. It is completely duplicated environment, so the cost will be more in multi-site concept. But then the effort that we take for recovering will be very less because it is automatic failover. But whereas if you take backup, the effort that you take to recover will be very high, right? And then the cost is also a little less when it comes to backup and restore, right? So just give me a second. Yeah, so and then you have this Pilot Lite. Pilot Lite is you have some of the basic services which are available, which needs to be available for quicker recovery. You will have those minimal services like DNS setup, and you might have some load balancers and stuff which might be created and kept ready, but you might not be using it fully. Okay, we will understand all of these architecture one by one. So there are few more point of view. So how the recovery time objective corresponds to all these four strategy. So when it is when you're going for multi-site active, the cost is high, the complexity is high, but then the impact will be very less. Okay, the cost of business impact, which means like there will be very less financial loss for your organization because you have implemented a very good multi-site strategy. So if there is a issue with one particular region or site, still your business can continue to run and you will have a very less financial loss. So you have you need to understand how much is the recovery acceptable recovery cost, so that you can plan for it. See, with warm standby, you will have servers in a very passive way, but then they will fail over quickly when there is a issue. But this is fully automated failover, but there is some manual work in warm standby because it's not completely automated. So as I told you, this is fully automated failover, but here we need to do some kind of minimalistic work. I will show you some architectural example, and the amount of time your services are impacted is very high in backup and restore. Backup and restore, the service interruption is maybe 1 day or 2 day because until you recover it, there will be a lot of downtime. So similarly, on the recovery point objective, you have a very good quicker way of recovering from the disaster, because you can quickly automatically fail over between the sites here. And if you look at here, there will be a lot of data loss if you're going with backup and restore, because you will restore yesterday night 10 o'clock backup, and the impact if it has happened at 5 p.m. or 6 p.m. in the next day, completely all the content that has been changed from yesterday 10 p.m. Until today 5 p.m. all the data like the complete 12 hours plus 14, 19 hours of data has been lost there. But if you're talking about multi-site or warm standby, you'll have continuous data replication, and that will have very minimal impact to your business. Okay, just a second. Let me switch to this slide. Okay, so any questions so far on the four strategies that we talked about, and I'm just going to explain about some disaster recovery tips. Okay, I'll talk about the tips later, but any questions on the planning and the strategy? Okay, so yeah, go ahead. Murugan, your audio is very low for me. Maybe your mic is misplaced, or you are not speaking closer to your mic.
Can you hear me now?
Yeah, it is better now. Yeah.
Yeah. So the pilot light you said, right? This I don't understand actually. See, most of the organization we could see so far, I was seeing is backup and restore options there. Okay, mostly. The pilot and restore, no, just once again recap it, please. Just I have slight confusion on that.
Okay, okay, I got it. So let me explain you what exactly I'm talking about when it comes to Pilot Lite. See, yeah, this is backup. Yeah, so this is an example of Pilot Lite. Okay, so Pilot Lite means you will have the database continuously replicating on the back end. Okay, so only the database level data replication will be continuously happening, but you will not be paying for the virtual machines or the licenses for the front end application servers, but you will have the systems, the data that is replicating, and you can quickly recover from the backup. So to quickly restore the system, maybe like the application server backup will continuously happen. You will create the servers in case of disaster, but the data need not be replicated. It will already be there in the destination system. So this is Pilot Lite. Okay, so we'll have a light amount of data that has been systems that is already running on the destination side, but you will not have the complete environment running. So you'll have the load balancer ready, you'll have the snapshots available, and then you'll have to just create the front end service and then point out to the database and bring this secondary environment up and running.
Okay, within lesser time we can like compare to no to then build up again, give it back.
I don't know. I was completely. Is it only for me, or you guys are able to hear him properly?
I'm not sure. Maybe my mic having some issue. I'm not sure for that. Sorry for that.
No worries.
Unable to hear him properly.
Unable to hear, right? Okay, fine then. So we will make use of the chat window if in case you still have if you're still lacking clarity. Okay, so Pilot Lite, you will have a very minimal environment running on the secondary location, secondary region, and you will have the Route 53 elastic load balancer, and the database replication will be there, but you'll not have the complete environment on the destination side to mitigate the failure. But with backup and recovery, see, what you will be generally doing is you will do a kind of um, in within the region also you might take backup, for example, from one availability zone to a secondary one more availability zone. You can have DR concept in within the region, or it can be between region also. So this is like, as you clearly said, there is nothing like no services are running there, but you will have only storage consumption cost, because you are taking a backup and keeping it ready on the same region or in a different region. See, it all depends on the data residency requirement, right? Some customer will say, my data should not go outside of UK or Germany or Ireland or whatever. So in such cases, you have to stick to the same region. You cannot have a multi-region for them. So you need to ensure you tell them that. Yeah, I will talk about that quickly because I have not covered it. So there is two different strategy again. Placement strategy. Mostly customer will go for 60 to 70% will go for multi-region, and a few customer will go for multi-AZ strategy. See, mainly AZ is what? Availability zone. Availability zone is what? Two different data centers, and this is within the same region. Okay, especially in Europe Ireland, Germany, these kind of customers, they generally don't want their data to go outside of a region. So generally we go for within the same region disaster. So this can help you with to recover from floods, power outages, and maybe regional disaster and so on at the data center level. But if you have complete data center level impact, if to recover from multiple data center level impact across distinct locations, then you go for multi-region strategy. Multi-region means you are having two different geographical AWS region having the active and passive or active content, so that you can quickly recover it. So customers based on the data regulatory standards and GDPR requirements or data residency requirement, they go and plan for it. Okay, so based on the data residency and legal requirement, you go and choose either multi-AZ or multi-region. See, completely it is different from how you have DR is completely different from on-premises. Sorry, yeah, data is data disaster recovery in cloud is completely different from on-premises. In on-premises, you know, right? Generally, we have two different data centers or two different set of systems. So we generally have on-premises. There is a lot of complexity. You have to take a backup, and then you have to have some tape libraries. The tape devices have to be copied over, or we need to have some transportation into the DR site, and we have to have replication of the data continuously to a different data center. But then still, even after doing all these things, both the data centers that we have got might have the impact and the risk in certain cases, like during the natural disaster, both the data centers might have impact. So here with cloud, with the DR strategy in the cloud, compared to your on-premises, see, it will be quick recovery, because see, we are talking about transporting the tape from one location to another location and trying to uh, rebuild the catalog, and then try to restore it and then bring the system up. But here it is online, everything is on the disk, and you can quickly recover from the disaster. And again, the complexity is also very less compared to your on-premises. In on-premises, we never know when the content was backed up, what kind of backup tool version that we are using, what kind of catalog we have. There is a lot of complexity in on-premises, but in cloud, it's all reduced complexity. It is tool driven. You can just use the online options to fail over and fail back, and it is very simple and repeatable. You can easily do DR drill if a customer want to have a DR drill or a test or actual failover or fail back. Everything can be tested, and you have a easier option to test more quickly, more frequently, more easily, right? It's simple. You can do the DR drill more often compared to your on-premises. And on-premises, once in a year, they do the DR drill, and people will be very scared of that situation. And in the cloud, people started doing every quarterly and so on, because of the easy option that they have got, and the simple procedure run book that they need to follow. So there is a very lower management overhead when it comes to the cloud. And there is a, I mean, I would say there is a very less operational burden for the operations team compared to your on-premises. But in the on-premises, the operations team will be taken to all the corners to get this DR drill completed. So here it is very less management overhead, operational burden to do the DR. Okay, so and then in on the premises, if you want to automate it, it is very challenging. But in the cloud, to automate the failover or the drill, it is comparatively very easy compared to your on premises. Okay, so in on-premises, if you want to improve the recovery time, you need people will be asking for automation, and if you want to do automation, there is a very high chance of error, the script failing, the script not working at the right time, right? So in on the cloud, you have the tool-driven approach. You also get a lot of right-sized environment, not just having a duplicate environment. So some customers will ask for one if one physical data center goes down, they want to have a highly available situation in two different location. So mitigates single data center. Sorry, I'm just typing it in the wrong screen here. So this mitigates single data center failure, and the second option, it mitigates the entire regional failure. So you can just plan for it, and again, it's all depend on the budget. If the customer would like to have multi-region, and the data transfer between the region is chargeable, you know that, right? And even if you are practicing it, try to practice within the region, so that you don't end up paying too much of money. People will be interested to do a lot of things, but then if you're going and transferring data between two different AWS region, there will be a significant cost. And but for the production environment, yeah, they have to take the burden of that particular cost, and then that will help them to quickly recover, right? So let me just move on. So these are the two strategies. What I will do now is I will just start the lab, because it is already an hour since we started. So we need to start the lab now. Sometimes it might take more time. So let's do that. Yeah, let me go to the EDR console. Okay, so these are the steps that we are going to follow when it comes to the lab. Okay, let me do one thing. I don't think this looks good here. Okay, so we are going to follow the steps. First, we need to set up the service. Then we have to install the agent on the source server. And if you want to do it via your VMware vCenter, then you can handle it in a much easier way. And if you are doing it on each of the servers, physical servers or cloud-based system, then you have to install the agent on the source server. Then we have to start replicating it. And as part of the replication, the data will be accumulated in a staging area. And after that, it will come to the actual location. Let me show you a diagrammatic explanation so that you understand it. See, you'll have the source system. So at the disk level, the replication agent will start continuously replicating and creating the EBS volumes on the staging area. So this is the staging subnet, and you can create a test system in the test subnet, and then you can ask systems customer to do a user acceptance testing or system integration testing. And once they say it's all good, then we can start doing it in the actual failover subnet or the recovery subnet. So you have a staging area, and the replication server will start replicating all the disk. If you have multiple disk, it will go and create multiple snapshots and multiple volumes. So it is all at the disk level. So in on-premises, it might be a physical disk or a physical volume, and we might be creating multiple snapshots and multiple volumes in the AWS region. So it can be Azure to AWS. We'll also try Azure to AWS also. That shouldn't be a problem. And we'll also try AWS to AWS, so that you understand the lab, the complete step-by-step instructions quickly. So let's go and set up the EDR, and they are also talking about some permissions here. Let me open it. So they are asking about, okay, this service linked role is fine, but on a very high level, they are talking about multiple service role. See, if you want to select the exact minimal requirement, you can just go for the second listing, or else if you want to just go with a permission, then you can go for AWS service role for elastic disaster recovery. That one role should be fine. But if you have separate teams for separate activities, like for failover, failback, agent installation, you can just give them role-based access control. But for our lab, I think it is good to start with the complete permission for my account. So they are saying like rate per replicating source server. So there is a pricing element. So for each of the server, you have to pay 28 cents, or not 28 cents. It's lesser than 28 cent that we have to pay for each of the servers that we are replicating. Okay, so either it is AWS or Azure, you have some bill that you can anticipate. See, there are a lot of benefits. I will come to the benefits and features after we start the lab. So we have just listed only the top 4 benefits. And the use cases, I will come to the use cases. Use case, as you know, right? What is the use case? To quickly recover from impact. We are talking about high availability and resiliency here. So I'll explain these things, no worries. Fine. Let's start the lab. Configure and initialize. So first we need to set up, and we are in the setup screen. So first they are asking us which subnet you want to do it. So we are in North Virginia. So yeah, I think the subnet is the staging subnet. So data center 1G, I'm going to use for the staging subnet. So this is where you will have the replication servers created. So replication servers are meant for doing the replication. So whatever you'll have a source server and then the destination location, and this replication system will be created in one of the subnet where it will start copying the content from source to destination. Okay, so from source system to AWS, so this is the replication server. Last week also during the migration, we had replication server and the conversion server. So similarly in EDR also, you have the replication concept. So replication servers will get created in this thing, and if you want to change the size of the replication instance, and if you want it to be little faster, and if it is a lot of IO sensitive system and you need to quickly do it, you can also change the server instance type, but I will go for T2 small. That is more than enough for my requirement here. And you can also go and enable the service access, and it should have access to EC2 and IAM and the KMS. So the replication agent should have permission to 3 different services. One is to the EC2, and the second is the IAM, because it is going to call and do the activity on your behalf. We are going to use a service account rather than a user account. So user account is not preferred. Always go for service account. So that's what we call it as service access. And you can also select auto volume type selection on the destination based on the sizing. If you are replicating higher than 125 GB, then you can go and choose which volume, which type, and so on. And if you want to automatically replicate and encrypt whatever we have on the source side, you can also select these options. See, these settings can be changed at a later time also. You can also use some specific security group. Always use AWS Elastic Disaster Recovery Security Group. Okay, so you don't have to create it. So if you are selecting this option, automatically it will create a replication group and security group, and it will allow 1500 port, which is what being used for sending your traffic into the staging area. So TCP port 1500 is what will be used for continuously replicating the content, and that is the only port. If you are manually creating a security group, you can go and create it and allow 1500 port for transferring the data, or if you are selecting this option, it will automatically create a security group and it will use it. So that is the best practice. And if you have a kind of shared network where you have the application being accessed by the end user, and if you're using the same network for replication, then you can go and do a throttling. Throttling means you can restrict and limit the, for example, if you have 10 Gbps, you can just say I just want to give only 2 Gbps or 5 Gbps for replication, and maybe 1 GB or 2 GB for backup, and for end user access to the remaining and whatever, right? And you can also do the complete replication through the data routing channel can be defined through VPC peering or direct connect or whatever circuit. So if you want the data to stay within your private network, you can also do that. And if you have a direct connect circuit, you can also direct the traffic via that or through the VPN. And this is point in time snapshot. So you are replicating the content from the source location, and it is automatically going to take a snapshot and how long you want to store that snapshot in the destination staging area. So if you are sensitive about very critical systems, then you can have a very higher duration. So by default it will have 7 days, and maximum you can go for 1 year. Default is 7 days, and maximum you can go up to 365 days of storing your snapshot, but it is not recommended to have that much amount of see, I'll just go for 1 day because it is lab, right? Even if I store it for 7 days, if the data is getting stored for 7 days, there are chances that I might have to pay for it, right? And then if you are having some migration acceleration program from AWS, you can also enter that map ID. This can help significantly reduce the cost for some enterprise customers. So we don't have that map ID here. And whether you want to have an active or what kind of instance type you want to have, whether you want to have the same exact size on the source and destination, or whether you want to start with minimal size and then scale whenever there is an increase in demand, you can also select it. Okay, so I will just generally go with the same size as that of the source, so that you don't have any last minute challenges. And then you can also start the instances on the destination side, and you can also copy the private IP. If the customer want to have the same source IP after coming to the new region, you can also copy the private IP, and also all the tagging, everything can be copied over. You can also set the launch into the same instance ID also. So this is only applicable if you're migrating from AWS to AWS. But if you are migrating from third-party cloud to AWS, then this instance ID cannot be retained, but other things can be brought over, like the private IP, and you can bring the licenses. So if you have an existing licenses for Windows Server, this is only applicable for Windows. So you can bring your own licenses as part of the replication towards AWS. So this is applicable only for Windows. And this is where you are going to have the final systems created. So you can also select the same replication, or I mean, it is set to get created, but I will just go for my default SAN security group for now. But if you want to have one security group created, you can also have it created with 443 port allowed. And if you want to have some additional user data, or if you want to add some boot script or cloud in it to add some tools and stuff after replication to AWS, you can also configure that. Some of the customer will add some native tools on the destination side as part of the replication towards cloud. So you can do that. If in case you want to do it, you can review whatever you want. We have whatever we have configured in all these 5 steps or 5 stages, and you can change it now, or you also have the option to change it later time also. These are the settings that are all going to be used during the pre-launch and the post-launch. So here on the left you have the settings here. So these are the steps which we have configured. Now you can also go and change these settings anytime. Okay, now we have to go and start adding the source server, and before we start adding the source server, we need to have the IAM created, IAM service account created. So we'll go and create a different service account for this IAM. Okay, so last week we used this migration, right? Let me delete those things, otherwise my sessions are being shared in the internet, right? So it is a risk. There are chances that the access key and the secret access key can be misused. I'm going to create a new user. So this is for my replication, Stan replication demo 01. And I don't want to give management console access, but I need access for programmatic console. So let me go and select what I have copied. So this is the permission that I need. AWS service role for EDR. Don't give administrative control. That is not a recommended way of doing it. So EDR. What happened? Elastic disaster recovery agent installation. Elastic recovery console full access. Service role. Anyways, this is the tricky thing. So generally, like they change, I will just go for AWS Elastic Disaster Recovery Full Access for now. Maybe I don't know whether there's a version 2 also. Let me give both of them, and then let me create it. Click on next, and then create it. I've just given only EDR access. I'm not given anything beyond that. Oh, I think I made a mistake. Let me just delete it again, recreate it. Sorry about that. I missed to select the programmatic access. So optional best practice. Oh, okay. I think we have to move to Identity Center. Let's see. 1 second. What they're saying, if you're creating programmatic access through access keys, okay, you can generate them after you create IAM user. Okay, so a lot of people, lot of changes are being made in the console. Okay, stan rep admin replication admin 01. Click next. Then attach the policy. Elastic disaster recovery. No, there are too many things. Elastic disaster recovery full access. Click next. Click create user. Select this security credential. I don't know why they have disabled that programmatic option at the beginning, but anyway, so we will create the access key here. So let me go and okay, they're asking what is the purpose. If you are asking if you are going to use it for application, I mean other is fine. Click next. Just say service account for AWS disaster recovery. Create access key. You can copy it and keep it for your reference. Better to download it and keep it. We never know whether there is a restart that is needed. Okay, so download the CSV file and keep it. Okay, done. Now we have a account that can be used. Okay, let's go back to the Elastic Disaster Recovery Service console. And here, now we need to go to the source server. Here is where we are going to add the source server. And see, always, I mean, I prefer to use the documentation on this console itself. So have it open in one of the tab, even in your work also. Whenever you are dealing with the service, have those release notes and documentation open in a different tab or a different window, so that you can quickly cross-refer them whenever you are stuck somewhere. Right. So let me go and create a server in one of the regions. See, in order to have some cost saving, anyways, I mean, either ways we are going to pay for it, because you have to pay a minimum amount here. So rate for replicating the server is $0.08 either ways, but then at least we will have some minimal amount, okay, per hour. So we are going to run it for 2-3 hours. So let me just see where exactly we can create one server. So we can create one server somewhere. See, I've got Elastic IP which is not attached. See, these kind of stuffs is going to cost you. Release them. So I think 1 week it is created and it is idle. So I might have to pay for it. Okay, fine. So let me go and create a new instance. and then keep it ready in one of the location. Maybe I will create it in data center 1 or data center 2. So I will just call it as stan AWS server stan web server 01 or 001. And don't worry about the systems or OS, you just need something. And here you can just select stan Jan 2024. Hopefully it is there. This key is there. And you can just select whatever you want and just go and create it. This is just, I need a server to practice to show you the demo. You can just create with your stuff, and if you want to add some web service or whatever you want to do, you can use the init data. Possibly that will be easier to have your content. Let me just go and copy the content here. Desktop stan demo. Files are getting too many files are getting created. Stan demo. I think this is the one. I can just use something. Okay, welcome to AWS with Stan. Some content on the system. So this is going to have some web server install. HTTPD package will be installed on that server, so we can test something after the system gets replicated. Okay, some content. Fine. Let me launch the instance. So, oh, sorry, I don't know. I missed. I don't know which data center. We have to select the VPC and data center. So when you are creating it, ensure that you are checking that. Maybe let's see where exactly it is getting created. Okay, fine. Okay, so it is created in US East 1A data center. So this is a separate data center, right? And I will try to replicate it to either C or D, because in North Virginia you have got 6 data centers, and we can replicate it to any of the other data centers we have got. Okay, let it get created, and once after it is created, I will log in and show you how to install the agent. These days it is very quick. It takes very few seconds to get the system created and running. So I will go and copy the instructions on how to install the agent on the source servers. Okay, so installing the replication agent. So first we have already generated the AWS credential. Now we need to install the AWS agent. So first we need to download it. So I think this is the policy, right? AWS Elastic Disaster Recovery EC2 instance policy. Okay, let me just go and ensure that I have this policy there. Otherwise, it is going to be a tricky thing. Let me go to IAM. Users, replication, add permission, attach policy, search for that. Okay, yeah, this is the one we need. Okay, so AWS Elastic Disaster Recovery EC2 instance policy. Add the permission. That's enough. So now I can also go and add it to the EC2 instance which I am replicating. So that way it makes things very easier. So what I can do is I can go to this instance. I don't have to really do this, because if you are migrating from Azure or GCP or other cloud, you can just enter the credential. But since it is AWS to AWS, you can also do this option. You can use this option. It is an alternate method. Directly, you can go and give the permission. Go and say modify IAM role, and you can just select the role that you have created. Oh, sorry. I have not created the role, right? I've just created a account. Yeah, but in case, if in case you want to create the role, you can also do that. This is another method. So you have two options. I will show the second option now. You can either do it via the user account, or you can do it via the IAM role. Okay, so these days IAM role is also being preferred. So AWS account, this is for EC2. And then you can just go and select the policy that you want, and then click next. And then so you can just say stan AWS EDR role 01. Okay, so I'm just adding my name always, just to ensure that it is different and we have created it. So just go and give it a refresh here. and hopefully we will be able to see that. Just type for stan EDR, stan AWS EDR01, save it. So this way you don't have to really give the access key and the secret access key. So now I can just connect to the system to install the agent. Or first we need to download the agent first, and then only we can go and install it. So let me go to the console here, go and first follow the, so it is for Linux, right? So you have the instructions for Linux and the Windows. So you can just go and so this is something which you need to be aware of. By default, the Linux installer will create a group and a user with the same name, AWS-replication. So you need to inform the customer, because in some of the systems, they will ask why you have created additional account. Okay, this is not we creating it. Automatically, the agent will create two things, one group and one account, one user account under your system. Okay, and it will also add it to your sudoers file. See, whichever region you are planning to download, you have to replace this region. If you're downloading it from US East -1, you can just change it to US East -1, or if you want to change it to Asia South AP, Asia Pacific South AP-South-1, you can just change the region. On the topmost right, you have the region, right? You can just go and pick up the region that you want to do it. See, here I have to replace it with US East-1, but if you're doing it for Mumbai, you can change it with AP-South-1. So that will quickly download. See, this is like very small MB file, but still they are telling us that it's good to go and change the region to fast track the download. So let me go and download it. wget command is for downloading the content. Okay, what has happened? Okay, so let's wait. I can try to switch to sudo vers the root user. Okay, let me clear the screen. Sudo -i, and then now I can just download that file. So this is the initialization file that will trigger the replication installer. And once after we start the replication installer, it will start replicating the content to the destination region. So now let's go and check a couple of more things. We have downloaded it. Now we can just start installing the agent. Before we install it, we might have to go and give the permission, executable permission on that particular system. So go and add the executable permission. So it is asking me which region. So we are going to do it for US East 1, right? And then it will ask us the uh, access key and secret access key. If you have not given the IAM role, it will ask for the access key and secret access key. You have to give these two content there. I mean, these two information there. And now it is asking me whether I want to go and replicate all the disk, or whether I want to replicate only certain volumes. I've got devx VDA, and then if you want to have only couple of volumes replicated, you can just copy the device name here, and then you can enter it here. So either you can just give like /dev/xvda comma /xvdb and so on, or else if it is older SCSI disk, it will be /dev/sda and sdb and so on. You can just selectively enter the content here, or if you want to replicate all the disks, you just press enter. It will start replicating all the disks. It is 8 GB of disk, single disk. It will start replicating now. So it is going to download the agent, and okay, it says installation failed. Okay, so let's see what happened. Last week also we had some issues with the Amazon Linux. I'm not sure if they have the content already there. Okay, so yeah, this is how it generally asks us. Okay, let's try. I'm not making any mistake here. US East-1, yeah. Let me try to do one thing. I will try to remove the role. And then see if that helps. Or else we'll also create one more Ubuntu system. Mostly like these systems are having the agent by default. Yeah, so it is asking for the access key. See, that is the difference of using the IAM role and not using them. Fine. Okay. So, okay. Still downloading replication, installing AWS agent installation failed. Okay, let's see. Let's do one more thing. You can also do a manual installation, but let's see. Do you have any inputs? Someone has come out of mute.
Yeah,
Yeah, go ahead.
Stan, in the location part, hope we should want to give the destination location, Stan.
Yeah. See, what I'm trying to do now is I'm trying to do it within the same
Okay,
region. It's not always we need to go for a
okay,
different
okay.
region. See, if you're going for different region, we need to pay for it. That's the reason I'm just trying to avoid different region. But I'm going to create a system in Azure, and then we are going to replicate from there, from different cloud to cloud. But here I'm just trying to, and I got your point, but it's not always the same region. Okay, you can also go with
Okay.
within the same region also, and you can also go. So I think there is some issue with the Amazon Linux. Let me try to create one more system, and I'll find out what's the problem. Let me just say stan AWS server 002. Let me create it. I think for Ubuntu, we have to, I don't have the script. Okay, let me start it. Meanwhile, I will also log into my Azure system. Okay, I think we are almost closing to the break time. So I'll also create one more system in Azure. Just give me a second. I will log in and, okay, let me do this. So re-log in. Here from Azure, it is going to be 30 GB. It's going to be a little higher in size, but anyways, let's go and create it. Create an Azure virtual machine. This can be any location. Stan Azure VM01. I don't want to have anything redundancy, nothing. I can just go for the standard, and then I can go for 20 is also fine. X86 is fine. 416 GB. I can have a different credential. Okay, fine. Let me also allow HTTPS. Maybe I need to check the security group that I'm using. Maybe it is blocking from accessing on that specific port. I've given the permission. Okay, let's see. Let me just complete this. Let me, should I have to do anything? No, right? Okay, let me create it. Let me go here and then try the system now. So let's try the IAM role method, and then we will go for the second option. So we'll see both the steps. So this one, before we go and do that, let me go to actions, select the system, try the IAM role method, stan AWS EDR, update IAM role. So connect. Sometimes this will also help. AM update -y. The repositories might not be. No, I think it's not permission. It's not download issue. Downloading is happening, but it's more on the permission side, or maybe the agent is already there in this system and conflicting. Possibly that is the reason. But let me just close this one and then we'll try this first. So we can just say apt update y 60 page. Okay. Just give me 1 second. Yeah, let me just do one more thing. So generally, I don't think the firewall will be an issue here, but let me check the Ubuntu firewall. Available application, Apache full, Apache secure. Okay, so just Apache, it's not Apache 2. Okay, so I can just go and allow it. It's only single, right? Okay, fine. Apache should be okay. Yeah, so I've updated and I've just allowed the Ubuntu firewall just to ensure that it is allowed. Let me also check the status. It is not a mandatory thing, so it's already inactive. Okay, so if it is active, then we can go for it. If it is active, you need to explicitly allow it. If it is inactive, then you can leave it. So whatever we have added, it's not going to be a big thing. So, but we will add the service to start as part of the machine startup. See, after replication, it might systems CTL will start it. Okay, let me just. Okay, fine. This should be okay. I'm not going to spend any time here. I will just make very minor modification because I just want to show you that the after replication the systems are working. I had too many code here. Let me just this is the default welcome page. This is the paragraph. Yeah. I'm just changing the heading. Same thing. We can also do it on my. Okay, it's fine. Okay, fine. We have a system. Now we can start working on the replication. So before we do that, we can also check whether the system is responding on the network and whether it is accessible. Okay, it will take few seconds for convergence. Okay, let it work. Meanwhile, what I will do is I will just copy the code and then start doing the same. First, we need to download. I think we already have it in the notepad, right? We can just copy the same thing, download it, and then install it. Okay, let's go and install it.
Stan, that is hope that is two different commands, Stan. Am I right?
This one is to download.
First
Yeah,
we have to install the chmod, and after that we have to install the
yeah,
dot
yeah. Semicolon is
AWS
fine.
RPA.
Yeah, semicolon is fine. That should be
Is
okay.
it okay?
Yeah,
Okay.
yeah, yeah. If you are using
Oh,
semicolon, it will execute both the commands. Yeah, yeah. Thanks for
okay.
just sharing it. But yeah, it will work. There are two different commands. But if you are using semicolon, you can have multiple commands. Yeah. So let this try, and then we will also try the Azure system also the same way that we tried. I don't know. Let me quickly check the security group. This is the one. That is wide open only. Let's see. Maybe it takes a lot of time. Last week also it took some time, but yeah, let's not waste time on that. Let me just go to this resource, and then let me log into the system, which is in Azure platform. So let me run as administrator. Stan at Okay, I've logged into that system. Now let's do the same thing. Copy, download. Yeah, before that, let me also install the agent. In okay, let's see. So do we have something like HTTPD in Ubuntu also? Let me try that. apt install HTTPD. That will be much lighter. Oh no, it's not there, right? I was wondering. Okay, we have Nginx, but that's fine. So let me just go and do the small similar stuffs. VI index, same thing. So this time I'm not going to do a lot of things. I will just change only a couple of lines. Insert. Okay, fine. Systemctl Apache restart. Sorry, systemctl restart Apache. Should I use two? Okay, fine. So let me also go and check the security group. I have to allow 80 port here, same like your security group in AWS. Here we call it as network security group. We need to allow HTTP port. And if you want to allow the 1500 port and 443, you can also allow that 1500 port. Custom port 1500 for AWS data replication EDR. 340, some from rule number. Already 330 is used for HTTP, so it is showing error. Fine, that's fine. So we have to allow the 1500 and 443 port, which is allowed. Now you can go and copy the IP address of the system and then try to access it. If it is working, then good. These days, yeah, it is working. So AWS would stand from Azure VM, and then it is also working. EDR demo. Okay, so we have some system here. So we'll start playing around what we did in AWS. So we are migrating from Microsoft Data Center, replicating from Microsoft Data Center to AWS Data Center, Amazon Data Center. So we are going to have two systems, one copy in AWS, one copy in Microsoft. And if one of the data center goes down, you'll have systems available in different location and different companies' data center. So I want to replicate it to East US 1. It will going to ask for the access key. It will ask for the secret access key. You want to replicate all the disk. Yeah, fine. There are two disks in Azure. This is the problem. They will have one primary disk, and again the secondary disk is 30 GB because we have 16 GB of RAM. It will be double the size of your memory, virtual memory, the secondary drive. So it is going to copy 60 GB. Fine, that's fine. So let it do. And now we can come to this console. At least you should start seeing this one. Okay. So there is a source ID that has been created for each of the system. You'll have a SN ID, source ID, for the system as well as for the network. So SN is source network ID and this is the source system ID. So now if you go to the EDRS console, you should start seeing some source system, at least for the AWS system should be available in the source system here. So we should start seeing some systems are getting replicated here. So you can identify by the IP address. So it is initial sync is going on. So it is replicating from this data center to this data center. See, second time when we created it, we have created it in 1B, the second system, whatever we created, right? It has got created in 1B data center, but we have already configured that all the systems, the default launch should be in US East 1E data center. So that is the reason it is creating it in that um, data center, US East 1E data center. So we already configured that post-launch settings. You can change it anytime if you want to add some additional CloudWatch agent or Systems Manager agent as part of the replication. You can also do it. And so let's go and check this thing. So currently you have this launch template. So if you want to change something, you can change it. Okay, fine. For now, it is okay. Let me just wait for the system to come. So we have one system that is replicating. This is the system. So if you go and check the IP address, it is 172 ending with 107. That is what we are seeing here. 172 ending with 107. In the next few minutes, you'll start seeing this Azure system also there on the AWS console getting replicated. So we'll see the lab for the AWS to AWS. So that way it is quick. Even when you are practicing, you try to do this. So that way you learn the complete step-by-step instruction and you pay very little cost. Okay. Otherwise, if you are doing it between region, there is a lot of cost. Again, we are doing it from data center to data center, from Microsoft data center to Amazon data center. It is going to charge me some amount, but that's fine for me. Okay. At least you get to understand how we work between data centers. Okay, how about this one? Is it still, I don't know why it is taking such a long time. Let me go and check the instances. AWS server 02, copy it, and then I'll try to paste it in this machine here. Any inputs? It's working. Okay.
Yes, that port site is already working in my system very long
In
time.
your system it is working. I don't know why. Last time also I had the same challenge when we were seeing the demo for migration. It did not work in my local machine, maybe some DNS issue, and it worked in the Azure virtual machine which I've logged in. Anyways, fine, it is working, so there is no issue. So you can see that the replication server has been created. This server has been created with T2 small for replicating the content from the source data center to the destination. So if you go here, you'll start seeing some snapshots getting created and some volumes getting created as part of the replication. So it will take a couple of minutes to list down. So it is replicating. See here, you can see there is a replication server and this is the volume associated with that replication server. So there will be a base volume that will be created and you can, in few minutes, you will start seeing some snapshots and volume getting created. Yeah, you can see there is a base snapshot that has got created. So whenever there is a replication active and getting progress, you will start seeing a new snapshot and volume getting created. So this is from my on-premises. See, anything outside of AWS, it will be considered as a on-premises. Either it is in Microsoft data center or your own data center, it is on-premises for AWS. So everything will be listed as on-premises if the server is coming from outside of AWS region. Okay, so there are two systems that are getting replicated and synchronized. So let it work in the background. Maybe we'll take 10 minutes break and come back. Um, and then we will continue with some more theory part. Any questions before we go for the break? Okay, so let me stop. Okay, so I could see that the snapshots are getting created after the 100% data copying. So we can now see that some more snapshots should be available here as part of the replication. You can see that there are some disaster recovery snapshots are getting created. So it will keep creating, and even you can see there are a couple of more snapshots that is getting created as part of the Azure virtual machine replication. So let this continue in the backend, and I will show you how to how to switch over. And as part of the migration, as part of the disaster recovery, so there are certain checklists that you can follow. Okay, and even I follow this in every single DR requirement. So you can also have this. First thing, you need to determine the recovery objectives. So we already discussed about that. Recovery objectives. So recovery objectives are your RPO and RTO. Those are the two recovery objectives. And as I told you, disaster recovery and the other one, the high availability, they are all close terms, but they are not the exact same thing. Okay, so when it comes to resiliency means that is availability of your service. So availability of your service can be measured in two different ways. So resiliency has two aspects: disaster recovery, and it has got availability. And for availability, generally, like if you are part of the SLA team or the OLA team, you might have heard about MTBF and MTTR. So for disaster recovery, you might have heard about these two objectives, and for availability aspect on your service level agreement, they will have these two aspects. So this is like mean time between the failures, and this is the mean time to recover when there is a failure. So whenever we are calculating the availability, so the formula is availability is equal to mean time between failures divided by mean time between failures plus mean time between recovery. So this is like available for use and divided by total time. The service was available for how much time is the available for use time divided by total time. You can keep it that simple. I mean, you can keep it simple like this, or you can also go by this formula. So maybe if you are in the SLA management team, so you need to be aware of how the SLAs are calculated, availabilities are calculated. So this is the formula. So generally, we might target 99.95 or 90 or 99. So based on the workload, based on the criticality and priority of the workload, so your priority will change. So when it comes to disaster recovery, we go and identify the recovery time objective and the recovery point objective. These are the two important elements we need to work with the customer. Second thing is we need to identify the complete set of stakeholders. I will explain what are it comprises of the technical team. It might be a, non-technical team, the business owner, application owner, all these people, right? Let me just see business owners, app owner, tech support, engineers, the executives whom we need to inform if there is a disaster. And in some cases, you might also have some third-party contractors, third-party suppliers whom we should inform, because maybe they might be supporting the application, app support, or vendor support team like hardware or whatever, right? And it depends on the suppliers, maybe application support or maybe hardware suppliers, we need to inform them. So many of the companies, they have this stakeholder list where we need to have it, and also we need to have this communication and escalation matrix. So this will be done by the program manager or the DR manager is responsible for communication and the escalation channels. So if in case we are not getting the part on time, whom do we escalate within the application team or the vendor, right? So we need to have the list of team and the complete chain of command is what they call. So they call it as triple C. The program manager will have the complete chain of command to initiate, like whenever there is a list of team whom to contact, and for network team, for hardware, or for any specific remote support on the data center, whom do we contact and whom do we escalate, and so on. And finally we have all the relationship information, so what they call interdependency information, dependency info, like which system talks to which system, and what are the different systems it connects, and the application layer, or what are the different systems that we have. So you will have a complete single source of truth, or a complete CMDB information. So this is more about the infra and the app details in a very detailed way, including the OS configuration, the apps that are running, the recovery procedures, run book, everything, right? So all the templates, whatever you need, everything should have to be here. Even if we are talking about AWS, we should have all the uh, CFT templates and all the content scripts and so on. Then finally, we need to have the technology specific stuff. Okay, so we need to ensure that we have the right technology. Right. Okay, so when I say right technology, see, we need to have a very reduced downtime, and we need to choose the AWS products and services, the right one for the right particular layer. Maybe some might have the platform as a service, some might have infrastructure as a service. So we need to think about sorry guys, I have power outage here, and as part of that, network is also fluctuating. So is my audio back to normal?
Yes, your audio is.
Yeah.
Fine, fine. Okay. So you need to think about the scalability, monitoring, and the manageability of the destination environment, because like we are migrating it to or replicating it to AWS environment, and we need to find out whether the system can be tested properly, and whether you have the options to manage, patch, monitor, backup, scalability, and all those aspects. And finally, you need to understand the incident response procedure. Okay, when there is an incident, how do we check on the destination side, the ITSM procedures, the change management, problem management, and other stuff. And then you also need to have some kind of detailed information, an incident recovery procedure also. They call it as incident response procedure. What if you have 99.95, how you are going to have um, the response taken? Mostly the site reliability engineers are responsible for having the incident response procedure. So generally they go and check certain things, how long your systems are impacted, or what are the trigger for the event or the outage. Okay, so who can be reached out when there is a issue? How do we differentiate the false versus correct alert alarm, right? So there are two things. Okay, so one, normally there will be a problem manager or the problem management team who will take care of um, Okay, sorry. Again, there was a small fluctuation. So I was just saying that mostly if it is a very small company and a mid-sized company, then I think the ITSM procedures like the problem management team can help you define the incident response procedure. But whereas in a large-scale company, you nowadays they are having platform reliability engineering and site reliability engineering who can take care of the entire site or only a particular layer, like for example if they are talking about database or a specific platform specific area, then we have separate team for that. Now they call it as action response procedure team or action verification process team. So what they generally do is they just check the DR drill exercise and then what kind of checklist we have, and then what are the plans that we have, whether we have all the necessary procedures and precautionary steps in hand. So these things will be tested by them. They will also do a check on the complete business process as well as the functional technical process. Then we have the actual DR drill. So we will perform the DR. We have to do it. The DR drill is different. Drill means we are just trying to see. This is very essential. So testing your DR environment is very crucial. People, a lot of companies take it, neglect it. A lot of companies they don't take it very serious, and we might be put into a real disaster. And that is when we will start realizing that we might have should have done the DR drills. So when you're doing the DR drill on a regular basis, then we get to understand how prepared we are and where exactly the run book is failing, or where we exactly need to update the playbook, and whatever failover test we are doing, we can also try and see how we are able to quickly recover. So this will demonstrate the ability of the team on how they can efficiently handle the DR situation, and whether the DR solution that they have in hand, whether it is adequate enough to handle it. So always stay up to date with the systems, the vulnerabilities, the risk register should have to be updated if there is anything that the team is complaining about, or if there is any backups that are failing regularly, or if you don't have a proper snapshots, and if you have some lessons learned from the previous DR drill, and we should have a project manager who is tracking all these risks and lessons learned, so that when we are going for the next DR drill, or when we are handling the actual disaster recovery, we will be much prepared with the risk register and the lessons learned. Finally, we need to prepare for the failback also. So failback means after we have see, failover means we are failing over to a different location, switch over from source to destination. And when the source site is functional, fail back from destination to the source. This is what fail back is called. Okay, so we should also be planning for the fail back. So these are the different checklists we should have, and I will also tell you about the precautionary checklist shortly. But let's go and see what's happening here. If we are in a situation to do a disaster recovery, we can also try that. So let's go and refresh it. Yeah, so one is ready. So this can initiate a drill now. So you can see the pending action is you can initiate a drill. So go to replication, and then if you want to edit the replication settings, you have the option to change it. See, for example, if you want to have a different staging subnet, or if you want to change some specific, if you want to exclude some volumes, or if you want to change the security group and so on, you have the option to change it now before you initiate it. So for that, you have to select it and then go to replication, and you can change the setting here. And here is where you have to go and initiate the recovery drill. Before you do the actual recovery, first you need to check the drill, and then try to select which recovery point you want to choose. This is the point in time backup which you have chosen, and we can initiate the drill. Now, as part of the drill, it will go and create a new system, and it is very quick. It will just quickly create a new system in the East 1E region. So you can see that there is a new system that is pending. It is the conversion server. So it is going to get created in the destination location. Both the replication server and the conversion server will get created in the destination location. See, there are two different systems, right? So one is your AWS EDR replication server. So this is going to replicate the contents from the source to destination. So its job is to create the snapshots from the source content. And we also have the AWS EDR conversion server. So this is going to help with creating the EC2 instances from the EBS volumes. In fact, it is a EBS snapshot. So it will do the conversion. It will go and create the system now. So let's refresh it. You can start seeing a new system coming up online shortly. So the conversion server is active. Let me go and delete the unwanted system. I think this system I don't want. This is the one which we had some challenges, right? Let me go and delete that, because it is going to impact my overall 750 free hours. Terminate instance. This I can just terminate. So let me just wait for 1 or 2 minutes. So it will initiate a drill, and then it will have a test system created for the DR exercise, and then for the actual stuff, we can have the actual environment. So now coming back to here. So these are the general checklist that we need to have as a practice for the DR runbook. But generally, as a technical team, if you ask me from technical aspect, what I will do is I will check the environment, whether the environment is reachable, whether there is any ongoing issues on my source system. Are there any incidents or problem ticket in the source machine? So I will just generally go and check the environment first, analyze the environment if there is any network related issues or disk related stuff, and then we need to define the workloads for the DR, which are the critical environments which we need to take care of. See, when we are analyzing it, we need to check at multiple different stuffs. We need to check the networking requirement, whether we have the adequate speed, configuration duplex settings, whether the OS is compatible, whether the application is compatible, and what kind of uh, antivirus we are using, what kind of anti-malware we are using, and what are the different tools we are using for backup, and what time is the maintenance window. So all these things we need to be aware of, the patching schedule, whether the systems are up to date. And then we have to understand the installation requirements, and you have a very detailed guide for both Windows and Linux. So you have separate instruction. You can also do Windows, but it is going to be a little higher in size. Then we have to understand the RPO, RTO details. So even as a technical engineer, we need to be aware of these things, and we need to find out whether we have the, sorry. Yeah, so whether we have adequate permissions. Maybe most of the times it might be admin or root access based on the operating system. And then whether we are working on the right AWS account, right AWS region. So most of the people might make mistake on selecting the region and the account. Sometimes people will go and mix with the non-production environment and production environment. So we need to be aware which environment we are talking about and where we are currently working. And very important thing is the staging environment has to be set in a very proper way. The VPC, the subnet, we need to have that separate from the production environment. So this is what staging environment is, what we generally use it for your testing purpose and the drill activities. But you should have the final environment also separate from each other. So separate environment for the actual workloads. Then you need to always check whether the replication agent is up to date. Sometimes people might miss it, and at the time of disaster, they might go and update it. So we need to check whether the replication agent on the Windows and Linux is up to date, and whether it has the right permission, whether the replication is working continuously happening. We need to monitor it, and we need to configure alerting if there is some failure. We need to get notified, okay, if there is any problem. Then finally we go and do a DR drill. This is the test failover, right? That is what we call it as DR drill. And we actually do the final, perform the final cutover during disaster. So this is how you need to have a kind of proper checklist. So you need to keep testing the workload as and when we get time, and properly check the account, region, permissions, the agent. So all these things has to be properly checked whenever we are getting some time. So these are the checklists that I generally do when I'm working on a DR exercise. Okay, so I could see the conversion server is now terminated. So possibly like you are getting the new systems getting created. Let's see. Let me scroll down. Let me go to the console. So, okay, so it says failed. Okay, some reason it is saying failed. Let's go and check that. Maybe there is a limit issue. Replication is 100%. Okay, let me go and check the events. Yeah, at times my maybe I'm having some limitation. Okay, let me go and check here. Status pending, launch status pending. Start the drill. East one. So source IP address. AWS with stand prod. Okay, fine. Let me check the next event. Source servers. So this is all looking good. Okay, let me try one more time. Job started. Okay, server info. So all good. C5 large. So this is another thing. They are recommending a very higher size VM for the destination for some reason. Okay, so this is only 8 GB. Yeah, that is fine. Okay, let's try again. Select it. Okay, let me try to change the size of the instance. So subnet 1B, this is fine. Oh, okay, we have already selected the same thing. Okay, instance profile, let's not do anything. Auto assign public IP address, no. So this is all fine. Let us check the edit one. So active, copy private IP, no. Yes, start launch. Okay, let me not start the instance and I will manually start it. Maybe there is some conflict. Let me save the setting and then try that. Or else let's try the actual recovery and then see what happens. So this is at the latest one. I'll go with the most recent data, initiate recovery. Let's see. So this time I have not, I don't want the system to automatically start because we are trying it in the same region. So there might be some issues with that. So now I should start seeing the new conversion server getting created and we should start seeing a new server. Let's see. And I don't know why they are creating a larger size VM. It is trying to create a C4 large, which is a huge one. Okay, so how about this one from my 89% from Azure. So between Microsoft and AWS, it is much faster these days. Only 10 to 13 minutes left. 13 minutes left. Yeah, you can also try this from your home lab or on-premises machine, but that is going to take a lot of time based on your broadband connection and speed. Okay, then. So any questions so far from anyone on what we have discussed today? So this is very important because most of the companies are expecting us to have some kind of knowledge on the. Yeah, go ahead.
Excuse me, Stan. Hi.
Yeah, go ahead.
Yes. This just I have one or two questions. First one is regarding this creating that DRPC from
Mhm.
Azure to AWS.
Mhm.
That time we gave that only region name. So we not to specify that AWS subscription ID or something. So how it will be pointing to this respective account?
Okay,
So
so the
this I have one.
initialization file that we have downloaded and the script that it creates, okay, it will go and look at the credential, okay, the access key and the secret access key. So this service account is unique to each of the AWS account that we have. So it will automatically start replicating to the account where we have this particular access key and secret access key created. So this is the installer script that AWS is providing us. So they have a mechanism to go and find out which account these access key and secret access key belong to, and it will start replicating to that AWS account.
Oh, great. It's very simple. Okay,
Yeah.
fine. Fine. Then I have that second one question
Mm-hmm.
regarding this, how to managing that VCP. For example, that production
Mm-hmm.
EC2 instance is a different VCP,
Mm.
and staging environment is different VCP, and DR site is a different VCP. So in this
Different
case,
VCP, right? What is that?
virtual private network service.
Oh, okay, VPC. Yeah, okay.
Private service,
VPC. Okay. Yeah.
So how that IP address and all, it can be some changes, correct? So how we can able
No,
to manage these things?
we can pre-create the virtual private cloud as per your requirement. So in reality, so we might not be using the default one. We will go and create a separate staging VPC and staging subnet, and production VPC and subnet will be different from the staging. So here we have just used different data center VPC and data center subnet. So we have made use of the different subnet from different region, but in reality, we will have a separate VPC for staging, separate VPC for production, and we'll have subnets created. And here in the Elastic Disaster Recovery Console, we will have to select that launch settings here. So we'll have to go and select what will be your um, destination network for your staging and for your here, like, sorry, let me close these things. Yeah, for your systems, what will be your default network? So you just go here and then you can change the subnet here. So you can choose which subnet you want to have your systems replicated. So you can generally route it. You can do a couple of changes. So through which network you want to do the routing. If you want to do it through the VPC peering, also you have the option to go and update it. You have the option to select VPC peering, and you can continue to have the same private IP in two different VPCs. Okay, but if you are creating VPC peering, then it will be a challenge. But if you're not creating a VPC peering, you can have the same IP range in two different virtual private cloud network.
Thanks. So for example, if we are in different region, definitely we have to create a VCP pairing, correct? Also,
Yeah,
if you are in a different cloud platforming, for example, Azure, so that time, yes, we have to create a VCP pairing, correct?
VPC. Yeah, that is sure. Yeah, we need to create a VPC for sure. But default VPC, most of the organization will never use it. Okay, they will use a separate VPC for these purposes. Yeah. Let's see. I'm having some issues here. Maybe the size of the VM that I'm trying is having a lot of issues. Let me try to refresh and check. False, true, false, read only, true, management event. Yeah, even I have mentioned it to be stopped, the disposition. Pending. Fine, let's see. Let's give it a couple of minutes. I think this is all done. Let's try. Okay, let's try the second one, and then I will check what's wrong with the other one. I don't know why it is creating C5 large. We should have selected. It should have selected a smaller one. Maybe let me try to change that 1 second. So go to the replication setting. So instead of that, choosing the default size, what I can do is I can point in recovery, data routing, always default dedicated instance for replication server. No, selected source server is fine. Replication server volume. No, I don't have. Okay, automatically replicate new disk. Fine. Auto volume type. Okay. Security group is fine. Throttling. Oh, interesting. I don't have the option to go and change the default launch. Edit. So active in AWS. AWS DRS will periodically update the AWS run based on the config. Okay, so let's see. Let's try to start. Don't start the instance. Save it. So we can also create a separate launch template for each of our systems if in case you want to have a different option. Okay, now I'm trying to see if it changes the instance type. Currently, it is trying to create a C5 large, which is a very high size system. So let me try to initiate the recovery, use the most recent, and then initiate the recovery, and then let's see. It should not create such a huge system because the source is T2 micro. Maybe the replication is creating a lot of CPU load and network transfer. So maybe it is trying to create a higher size compute instance so that it can mitigate the CPU utilization. Maybe that is the reason it is trying to create a C5 system. But looks like the replication, it's just the replication was complete and it is ready for recovery. So those things are perfectly fine. So I could see I have got the disaster recovery snapshots created. Even it has created multiple snapshots. We are able to see 3-4 point in time backup recovery options available. Okay, so overall, see, disaster recovery planning is like it is describing the detailed run book or the procedure that the organization have to follow using the tools and the IT systems procedure that they have got. Maybe they might have to follow the service now or the remedy. We need to follow all the necessary change request has to be created, and we need to provide the DR plan, and even the change manager will ask whether we have already tested this DR exercise before going for the actual DR. So there will be a lot of questions. So we have to have at least 2 times DR drill in a year. If it is cloud, it can be on a quarterly basis. On premises, generally you can do only once in a year because of a lot of complexity and dependency with the physical layer. You cannot have a lot of capacity available in the on-premises data center, but in the cloud you have a lot of capacity. And see, people get confused with backup and disaster recovery. So backup is making sure you are having an extra copy of your data. So when there is any situation where you need to restore because of a damaged file or a damaged object, or if you want to gain access to some content, you can use the backup to recover it. But disaster recovery is at the application level. So you have a quick procedure to access your application data and IT resources as part of an outage or disaster. So you have complete control at the applications server level or application data level. But for the backup, it is only data we are talking about, and we need to recreate the application server and then restore the data. So backup is different, disaster recovery is different. Disaster recovery is having two different complete site with the same set of systems. So when the primary region goes down with multi-site DR, the secondary site will completely take over the role, and then the end user will start accessing the contents from the secondary location. Okay, so let's see what's happening with the other system. We should start seeing one more server getting created. Let's see. No, it is having some issues. Let me try this. This is almost done. It is creating the snapshot. So once the snapshot is ready, we will try that. Yeah, so converted snapshots are getting ready. So we can also try creating a VM using this snapshot. Since it is AWS, see, we have alternate option. See, for example, I have this EBS volume, right? So which has been created. So using this volume, I can go and create a new instance, create a volume from the snapshot. And then I can just give some sizing and then give some name. So this is a manual method, but I don't prefer this. So this is what we call it as pilot light, or we can call it as a kind of active passive. Whereas we need to have an active concept for multi-site. So it will go and create a volume. Let's wait for that volume to get created. So it is now available. So what you can do is you can use this volume to go and create a, just give a second. Yeah, it is ready. So let's do one thing. So let me go and create an instance using the volume. test server 01. Or else let me do one thing. I will try to not create additional volumes. This is going to hinder the procedure, okay? Because there is a lot of content going on. Okay, let's give 1 minute. There is, we have tried already 3 times, right? Three times it has created 3 M4 machine. Okay, let's give it 1 minute. Let's wait for this one to complete. If this completes, at least we will be successful with that. Okay, it is still creating. Let's wait for that. Let's not disturb it. Okay, fine. Let's do one thing. Finally, we'll have one quick recap. See, there are 4 different strategies. So this is the final multi-site strategy where we will have complete set of systems available, and we'll have the DNS level redirection from one region to another region. So where we will have continuous replication, and you'll have the backend databases, the servers, everything will get continuously replicated, and we'll have a complete multi-site environment available. So you will have both the workloads simultaneously running, and the problem here is you have to pay a lot because the licenses has to be doubled, and the data consumption will be double, and with multi-site the traffic will be between 2 different geographical region. This is region 1 and region 2, so you have to pay for the data transfer out as part of the replication. So this is a very costly affair, but you have near zero downtime. So when the region goes down, or when one server goes down, or when database corruption, so you will still have the users going on to the other region and other server and accessing it. So you will have load balancing and auto scaling across different availability zone. Even if there is a single server failure or single data center failure or the entire region failure, multi-site active concept will help you to recover from failure in a very quick way. And this talks about how we do a VPC peering and do it. Maybe we should have tried that option, but anyways, fine. So we can create 2 different geographical region and create VPC peering, and that way it will be much faster, okay, when you're doing a replication. So this is like the failback that we generally do. So after we do a failover, we can again fail back to the source region. That option is there. I will show you. And then this is the very high level network architecture. So there are 2 ports. One, the DRS tool, the EDRS, the AWS EDRS tool, it controls the source environment using 443. It is the control protocol, and all the control is happening through HTTPS. And whatever the data getting transferred using the replication server to the destination, whatever the volume and snapshot that it is getting created, so it will happen through TCP 1500. So TCP 1500 is for data transfer, and for controlling and sending some command and instruction, it will use port 443. Okay, so it is a complete block level replication. Generally, it is compressed and encrypted over the network. So you don't have to really worry about the security when the data is getting in the transit. The data is always encrypted. It uses transport layer security version 1.2. So your data transfer is very secure by default, and it is done at the block level. And by default, it also has the compression enabled, so that the network consumption will be very minimal. So this diagram is something like you have a very small minimal environment. You don't have the auto scaling and load balancing on the destination location to avoid too much of cost. You'll have minimal instances running. So some people will do this. So they will have only the forwarding request to the destination, and we'll have a very minimal environment available in the destination location. So this is what we call it as warm standby. Okay, maybe let me put these details here. So this is called warm standby. So we'll have some environment available, not the complete set of environment. So we don't have to invest the complete licensing and stuff. So we will have 50% spent, and the production traffic will be inactive only when the region goes down, or both the data center goes down. The warm standby will start adding more servers. So you will have the auto scaling triggered when the users are start getting more and more on the secondary region. Then automatically the number of systems will increase, and it will scale down when the source environment is fully productional. So see, this is what we call it as warm standby. So this the small difference between warm standby and the pilot light. See, pilot light, yeah, it will be little different, difficult to understand. Both include an environment in the DR region, and it will have a copy of the content. But in pilot light, you cannot process the request without manual intervention. But with warm standby, the traffic will automatically start getting moved to the destination, and it will automatically add more servers and scale out, and start creating more servers based on the user load. So warm standby, it is in a way it is a little automated, and pilot light, it is we need a manual approach. So I'll show you the difference here. So this is the pilot light. See, in pilot light, we don't have the server. Okay, so we don't have the front end systems available, and we don't have to pay for the licenses, application server, and so on. So there is a very small difference between pilot light and warm standby. Warm standby has got a partial half the environment ready and available for handling the traffic. In pilot light, we have the backend data getting transferred. Only the data replication will have happen from one region to another region, and your volumes will be getting replicated. But the actual EC2 instances will get created only when the complete source region is inactive and not ready for migration. So, and when you're doing a failback, so it will have a reverse bidirectional sync from the destination to the source. Yeah, go ahead. There is a question. Any question? Okay, this is the typical backup and recovery objectives. If you have 24 hours RPO, RTO, then you can go for backup and recover concept. But here it is very, very minimal cost, because you are not completely involving the entire environment. We are just doing cross region. So you'll have two availability zone in the source region, and we will have the secondary location just occupying only the storage content. So we will be just backing up on the destination region, and when there is a disaster in the source region, we will use the content from the backup, and we'll start restoring and start creating the systems in the destination region. So this can be cross region, and it can also be within the same region. If there is a data regulatory requirements where you cannot go between region, you can just do it within the region, and you can create the systems in a different data center within the same region. You can also do a cross region backup, or you can do a single region. So for cross region, you do a S3 data sync, or you have a replication enabled at the S3 level, or even you can use the backup tool to replicate the cross region backup. So it depends on case to case, and based on the investment and budget, so you can go for the different DR options. Okay, so anyways, that is what I thought of covering from theoretically, and practically we have a system, but it looks like it is trying to create a very high size system. I don't have a free tier account, so I should try and see like what can be addressed. Even with Amazon Linux, last week also we had some challenges with migration. It should be seamless in Amazon Linux, but we were successful with Ubuntu and Windows system last week. Let's see how the replication works. It's the same procedure. Okay, it is finally two steps. We have to first do the drill, and then if you find out if the drill has been worked successfully and we have the test system, we will go and check whether it is accessible. We will assign a public IP and test whatever test cases we want to do. And once after the test cases are done, we can do the actual recovery. And once you do the recovery, you have the option, the failback option will be enabled. So if you want to move back to the source site and you don't want to have the destination, then you can also launch for failback, so that the source environment will become active. Okay, so let's see. And you can also check the job history here, and some of them were okay. So let's see. Let's go and check this job, which is the latest one, and then find out if there is any details available. Calling the run instance you requested. See, this is what the problem is. In 1E data center, you don't have the C5 large instance type. So, okay, let's do one thing. I will try the different data center if possible. So that way, at least we will be successful in AWS itself. I know that that is the problem, but let's see. Let me close this, leave, go to the source server, select it, go to replication, edit the setting. Now I will select a different data center. Better, I will try 1C. Let's see. And now replication is T2 small. This is all fine. This is okay. Let me save it and then try that. I don't know why why Amazon has limitation with certain instance type in some data centers. Let's try this. Let me try the direct recovery. Let me go for this and then initiate it. Okay, let's see what happens. At least we will try and see if okay. Let me just. I mean, we should have done this. That is what I was telling, right? We need to go and check the compatibility of the systems. Let me try this now. Maybe that way it will conclude whether I have the option or not. So let me go and check the C5 large. C5.large. And then I will go and check whether it is available for this data center 1C. Yeah, I think it says it is available. Let's see. Let's allow the console to take decision. But if you are trying it, maybe you can check it. Okay, if you are able to succeed with very smaller size VM, here C5 is a very bigger one. Yeah, so it is going on. There is a small RPO. So there is a difference between the source and destination system. 3 minutes difference is there. Okay, so in general, we are expecting a near real time. Yeah. Okay, you can see that now this time it is replicating to 1C instead of 1E. Okay, so that is where we need to ensure. So last time when we check the log, it says, see here also it showed some symptoms about the instance type, but here clearly it showed that the error is because we don't have the uh, particular type of C5 large instance in that data center 1E. Okay, so that is the only reason it was failing. Okay, so let's see. Hopefully this time it should succeed. So generally the migration sessions in the past, it used to take 7-8 hours. Okay, I've made people take a break in between and then we used to come back. But at least nowadays between Microsoft and Amazon data center, it only takes 1 or 2 hours. Sometimes it used to take 4 hours, 5 hours because it is 60 GB content, right? We have 2 different partitions that needs to be copied over. So these days it is much faster. So it is creating the initial snapshot. It will definitely take some time. It will go and verify, check if there is any latest update, and then it will quickly create a snapshot. So you guys also try it, okay? So that if there is anything that you have as a doubt, you can ask me. Even we can change this 1E to 1C, not 1C as some other data center. Maybe 1B or 1A also is fine. So the new data centers, like this is the 6th data center, right? So or 5th data center. So 1E. So let's go and check if there is some symptoms of systems getting launched here. Okay, so conversion server is active. Okay, there are 2 replication server. Interesting. See, this is for your Azure, Microsoft to AWS, and this one is for your Azure region to region. And you can see that the conversion server is still initializing and there is some work going on. So that is a positive sign. Something is actually getting done. Okay, the lag is increasing. Okay, so when you say lag, there is a difference between the source system and the destination system. The 6 minutes of data will be the gap. So that is what we call it as a recovery point objective. So how much is the data loss when you are recovering on the destination region? So I think 6 minutes is not a big time, but still some applications are very crucial. Even a very small amount of data will be a big impact. So let's see. So if there are any questions, yeah, feel free to ask now because I'm anyways just watching the replication synchronization is happening and completing. Okay, if not, then what I will do is I'll just stop the recording for a few minutes and then we will check. Start the recording. Okay, so now instead of going for US East 1E, I will edit the replication setting and then I will go for US East 1A. So that even if it creates a very larger size system, it will be okay, fine. Save replication settings. And you can just select it and then you can go and do a recovery. Yeah, so there is a very less latency, only 1 minute difference between the source machine and destination machine. But here it is saying a lot of lag between 2 different systems in AWS data center itself. And there is some challenges with the instance size. But anyways, here let's see what instance size it is going to try and create. And once after it is done, now we can go and check whether we have the same application access and so on. You can check the log. So it has got started. You can keep watching it if in case you are interested in watching the log. You can start seeing like what is happening. It is finished taking the snapshot and now it is going to start creating the VM. So it is pending here. So does someone have a free tier account? I think in free tier it will work. This is my pay as you go account. Maybe there are some. I mean, ideally it should not have such a restriction. But anyways, let me check why there is a regional level restriction of C5 large instances. Okay, let's see. Okay, then I will give, I mean, it will take at least 10-15 minutes. Okay, so I will stop the recording and resume it after the instances are available here, and then I will close the session. So anyways, I mean, if you want to stay back and see this, you can stay back, or else okay, let me do one thing. Okay, so for this system, okay, again, what has happened is with the recovery job history, I could go and check. It has tried creating it. So this time for the Azure VM, it has tried creating a C5 2x large VM. Again, the data center is 1E. So what I have done now is I went ahead and changed the default launch itself to 1A data center. Okay, so instead of 1A, I've just changed it to 1A. And then now even every default launch will go to data center 1A. Let's see what happens with the last attempt. Or else we will try a different region to region within AWS. So this is showing ready now. We can also try this once. Let me edit replication setting, try 1A. Okay, we can try both of the recovery. Let's see. This time both of them are replicating to 1A. And then see why there is a difference or why there is a delay here. The lag is because we initially targeted it for a different physical data center. Okay, which was 1E data center, and now we are moving it to 1A data center, which means like we are trying to see if there is any new changes, and we are copying the snapshot from one region to another region within AWS. Okay, sorry, one data center to another data center within AWS, and that is the reason we have to wait 10-15 minutes for the entire activity to complete. So it's not just matter of switching, it's just about changing the data center, and also it will go and check whether there is any data that has to be copied over, and it says like there is a 5 minutes lag in this AWS to AWS, and from Microsoft to Azure, sorry, Microsoft data center to AWS, there is a 21 minutes lag. So all these incremental changes has to get updated to the snapshot, and that snapshot will copy to 1A. So that is what it is doing now. So it is causing the stall, and it is resolving the issue. So there is some backlog it has identified, and it will copy it to 1A data center, and we will create the system. See, both the errors are very much similar. So even for Azure to AWS, so the error that we got is again the 1E data center is not allowing me to create the large instances from compute family. Okay, so let's see. I mean, if this works, or else I will record one region to another region within AWS, and I will also create a recording on VMware to AWS as well. Okay, let me stop.